Hello and welcome to Maths with Tiffany. Today we're going to be covering what a variable is. And as I've already put up here, a variable is just a placeholder for a number you are trying to find. So let's say that you were given $100. Let's change back to my pen. $100, and you need to buy basketballs that are $5 a piece. So you have 5 times the number of basketballs you need. So B equals number of basketballs. Because B is your unknown. And we use B because this is a whole lot easier to write than 100 equals 5 times an empty box with a question mark in it. That gets annoying. It takes a lot of space. We use variables to condense and to make it easier, so that way if you have more than one, like if you need to buy basketballs and footballs, you can use B and F. When with this, there's really no telling apart between things. So we have 100 equals 5b, and you divide each side by 5. So 20 equals b, because these 5's cancel. And so you can buy 20 basketballs for $100. Now let's talk about some rules with exponents, and from this point on I'm just going to use x, y, and z because that's what you're going to see. And I'll explain in another video why we use x, y, and z mostly. Especially in just long equations and when you're working with formulas and stuff like that. So with variables, let's say you have 5x plus 6x. So this you can simplify by using like terms because these both have x's. So these both have x in common. So what this is saying, this equals, because multiplication is just adding things a lot. So this is, so 5x, we'll do that in blue, is x plus x plus x plus x plus x. And then you're adding 6 more x's. So plus 1, 2, 3, 4, 5, 6. So in adding, you just need to add your coefficients here. So 6 plus 5 is 11, 11x. Because if you count these, this would be 11. So if you have stuff like that, you just add the coefficients, which is the numbers connected to your variables. If your variable doesn't have a coefficient, like if it's just x, your coefficient is 1. You don't have to write 1 because that gets annoying. Again, conserving, not writing, so it's implied that your 1 is there when you just have an x. Now what about multiplication? Let's say you have 5x times 6x. Well, this is saying 5 times x times 6 times x. So in this one, because multiplication is commutative, it's commutative, yay! So you can rearrange this to 5 times 6 times x times x. So 5 times 6 is 30, and x times x is x squared. I'll give you 30x squared. So if you're multiplying, you multiply everything. So you multiply the 5 times the 6 and the x and the x. So 30x squared. Now what happens if you have x's and y's? So say you have 3x plus 4y. Well, you don't do what we did up here because these are different numbers. So like apples and oranges. Because again, this is saying x plus x plus x plus y plus y plus y plus y. However, if you're multiplying, let's scroll down some more. So you're multiplying 3x times 4y. Well, this equals 3 times x times 4 times y. And we do it the same way. So 3 times 4 is 12, and then you have x times y. So you have 12xy. And those are really the rules of variables you want to just combine like terms. Okay, now what if you have a 2x squared plus x? Well, with this one, your exponents are not the same, so you can't combine them, because again, if we expand this multiplication here and what it's saying, you have x squared plus x squared plus x. And because you don't know what x is, there's really no way to combine this in a way that would make sense other than what we have already over here. However, if we're multiplying, you just add exponents. So like 2x squared times x equals 2x cubed. Because again, this is x squared times 2 times x. And x squared you can expand out even more, so you can have 2 times x times x times x, which is just 2x